Hi, my name is Pranav.
And I'm Arnav.
I will be talking about a science fair project today, and our title is
The impact of the angle of attack on a plane's distance. To start, let's review what we're going to cover. The first thing that we're going to talk about is the acknowledgments, followed by the purpose and hypothesis. Next, we're going to talk about the review of literature. We'll then talk about the procedure we took to do our experiment. Next, we'll talk about the results we got, the data, and including the conclusion. And to end it off, we'll talk about the discussion.
So first, we want to acknowledge and thank our parents because they helped us not like give up through the project and gave us anything we need, the materials we need for the experiment. And then we wanna take the time to acknowledge our advisor, Mrs. Sailaja. She helped us so much through the project, and she gave us advice whenever we needed it, no matter what time. So whenever we email her, within 5 minutes we get her response, which is so helpful.
Let's move on to the hypothesis and purpose. Our hypothesis was that the smaller the angle of attack, the farther the aircraft would travel. The purpose of this experiment is that we were trying to investigate whether the angle of attack affects how long a plane can go.
Next, we'll get to review of literature or the background for what we need. Okay, so first let's talk about the four basic forces and elements that are on aerodynamics on a plane. So first let's talk about lift. So lift is generated by air or fluid turning around and bending around the wings and the fuselage, which is the body of the plane. When a plane is flying, it needs enough lift, as the name says, to lift in the air. Throughout generations, many people have tried to explain the concept of lift, but most of them were proven incorrect. So now let's talk about drag. Drag is a mechanical force which is generated by the interaction and contact of a solid body with a fluid, like a liquid or a gas. Unlike multiple forces, it is not generated by a force field like electromagnetism. For drag to be generated, the solid body must be in contact with the fluid as in air in this situation. Drag is generated by the differences in velocity between the solid object and the fluid. There must be motion between the object and the fluid. This is by NASA 2021. The thrust is the force which moves an aircraft through the air. Thrust is used to overcome the drag of a plane so it flies. The engine does work. Does work on the gas and accelerates the gas to the rear end of the engine, resulting in thrust and the forward motion of the plane aircraft. Now, unlike the other forces, weight revolves around the gravitational pull. Weight is a force that pulls directly down to the Earth, since the Earth has a bigger mass. This would be a vector quantity, which weight is, since it has a magnitude according to the weight of the aircraft and a direction straight down perpendicular. The weight is directly proportional to the mass of the object. If the mass of the object is heavy, the stronger the force of the weight. Weight can play a part in making a plane fly. This is a huge problem that many airplane engineers face when creating a plane. Too much weight can cause a plane not to fly, and too little weight can cause a plane to collapse on itself. So for a plane to have the ability to fly, thrust and lift must be able to overcome the opposing forces of weight and drag. See figure 1 that's on the slide right now to see all the forces and the direction which they are at. So now let's go on to our next topic. So as I mentioned on the incorrect, how people have tried to theorize lift, we can talk about the two main theories that are out there. The first one is called the equal transit theory or the long path theory. This theory states that since the top of the airfoil is curved and the bottom is flat, then the air molecules that travel above have to travel faster than the molecules that meet up at the end of the same point. Because the airflow is faster, then due to Bernoulli's equation, Bernoulli's principle, the top part of the airfoil, cross-sectional shape of the airplane wing, has a lower pressure, and the bottom part of the airfoil has a higher pressure. According to Khan Academy, there's no year mentioned in the article. It was a horizontal flow of fluid. Points of higher fluid speed will have less pressure than points of slower fluid speed. The fluid, as in the air. And this travels throughout the bottom. The pressure differences causes lift. Even though this theory seems sensible, the problem with this theory is that there's no actual proof of air molecules meeting at the end of the streamline. This is assumed when people were creating this theory. Next, we talk about the second main theory of second main incorrect theory of lift. Second incorrect theory about lift is called the skipping stone theory. So, according to NASA, the theory is based on the idea that lift is a reaction force to air molecules striking the bottom of the airfoil as it moves through the air. Because this is similar to the way in which a flat rock is thrown at a shallow angle skips across a body of water. It is called the skipping stone theory of lift. The theory is based on a way of a stone skips on a pound. So, and then you can see the diagram which demonstrates this. So now we talk about the parts of an airfoil. So the first part of an airfoil is called the chord. This is a line from the leading edge, which is the front of the wing, to the trailing edge, which is the very back end of the wing. There's another aspect of the geometry of the wing, which is called the camber line. So according to Nakamura, one of our sources, this is the point halfway between the chord and upper wing surfaces. Then comes one of the most important aspects of the airfoil, which is to our project, which is the angle of attack. This is the measure of the direction of the wind to the chord line. This is from Nakamura, 1999.
Now that we reviewed our literature, let's move on to the procedure. To start, let's talk about materials. The first thing we need is a protractor, 30 regular printing papers, a ruler, data table, pencil, and measuring tape. So the procedure we took included the steps to making our paper airplane, as seen in the diagrams below. Then we conducted our experiment, and here were the results. This was our data table, which included the angle of attack and distance traveled, which also got put into a graph, as seen here. And as you can see, we come up with our conclusion, saying that the smaller the angle of attack, the farther the plane travels. And like our hypothesis said, so this shows that our hypothesis was supported.
Okay, now we get on to the discussion. So we're going to talk about the error analysis, like the things that could have caused the experiment to be affected, and the results from the experiment. So first, some factors that might have affected the plane's trajectory is the path that it goes. This is the fact that paper planes can sometimes go in unpredictable and veer off in bizarre directions. This can cause some of the data to be outliers and affect the average distances. And this is why we did 2 trials for each angle of attack of the plane. We can use the averages of the data to get the precise amount of details rather than doing only 1 trial per angle of attack. So the Table 1 and Figure 2 shows an overall decrease in the distances that is traveled by the paper airplane. In the data table, the start shows a distance of 100. It shows 339.73 centimeters, which is for 15 degrees of angle attack. While when you look on 40 degrees, you can see the angle of attack has the distances traveled has significantly decreased to 103.51 centimeters. And then we have to also talk about in discussion on other research that has done on this topic of aerodynamics. While we have talked about how aircraft and spacecraft are related to aerodynamics, there's also other uses for it, even in biology. So a person named Sanjay P. Sain wrote a book on this and researched on the aerodynamics of insect flight. So this shows that not only aerodynamics is applicable on spacecrafts and aircrafts, it can also be applied in the daily use of insects and other animals. Basically, this is intriguing to us because we thought the only applicable of aerodynamics was only in flights. That's it.
So thank you for listening to our presentation. If you have any questions, email us at the following links.
Thank you.